Here, as you can see, this green LED is glowing here, and currently we are around 3.2 kilometer away of our transmitter. This is not any kind of line of sight. So these are my E32 LoRa modules from eByte. In this video, I will test the range of this LoRa module in urban condition, both indoor and outdoor. I will also talk about the hardware setup for the transmitter and receiver part, and I will also give you the testing code of these LoRa modules. LoRa modules are basically RF transceiver modules, mainly used with microcontrollers like Arduino, Raspberry Pi or ESP32. These are RF modules unlike NRF or other 433 MHz RF modules, but LoRa stands for long range. It means these modules can communicate between them over a very long distance without consuming a lots of power. As these E32 modules can communicate up to 8 to 10 km on directly line of sight according to its datasheet, and the reality we will check in this video. Here I had used Arduino Nano for both transmitter and receiver. That's why the programming will be done on Arduino IDE, and Arduino IDE is the most familiar for everyone, I think. And I will also talk about antennas like these rubber ducky stock antennas or this kind of monopole antennas specially designed for 433 MHz, because these eByte modules does not come with any built-in antenna. It just come with this kind of SMA connector, so you have to purchase proper antenna for these modules, and the transmission quality and range is fully dependent on the antenna. And I will also talk about how to make custom antenna for these modules, because as you know, I am a ham radio operator and ham radio operators are pretty good to make antennas. So let's start the video. So at first, let's talk about the hardware part of the project. Here we had made two units of it. This acts as a receiver and this acts as a transmitter. This is transmitter, that's why there is no any display or anything other. Here is just a RGB LED if you want to indicate any kind of status like low battery or anything. And this is our receiver section, and this is the battery for the receiver. This is a 3-cell lithium-ion battery pack, and as you know, this is a receiver, that's why here is a OLED display also it. This is a 128x64 OLED display normally used with Arduino like projects. And this is the E32 433 MHz LoRa module here. Here is also a RGB LED for indicating any kind of status. Inside it, here is the main microcontroller Arduino Nano, and these LoRa modules pins are 3.3 volt tolerance only. They cannot handle 5 volt, otherwise they will burn. So that's why here is a 5 volt to 3.3 volt logic level converter. As you can see, this red module is the logic level converter here. This is the logic level converter. So basically there are 4 components in the receiver: the microcontroller, which is Arduino Nano, the logic level converter, this is the main E32 LoRa module, and this is the display unit to display the incoming received data. Let's talk about the transmitter. So this is our transmitter unit. This is more or less the same with the receiver unit, because these modules are actually transceiver modules. It means they can both transmit or receive data. It depends on how you had programmed that. So here is the E32 LoRa module. This is our main microcontroller, which is Arduino Nano again, and here this small is 4-channel logic level 3.3 to 5 volt converter. And in both circuit I had add this 7805, which is a very common 5 volt regulator, because if I run them for a long time, and also this LoRa modules consumes a lot of power, so I don't want to depend on the 5 volt onboard voltage regulator of the Arduino Nano, because in that case the Arduino Nano and the E32 both can burn if the onboard voltage regulator of the Arduino Nano fails. That's why here I had used THT7805 voltage regulator with proper heatsink here, so it can run for a long time with proper heat dissipation. And here is also 2 capacitor and a reverse polarity diode also for protection. And here is also sensor port here. Here I had kept 3 pin. The first one is 5 volt, last one is ground, and the middle is the signal pin. Here you can use any kind of 3-pin sensor like DHT22, DHT11, any kind of analog sensor like light sensor, rain sensor, or any kind of. So you can program the Arduino Nano to collect the data from the sensor, and you can transmit through the E32 LoRa module, and this LoRa module will receive the data from the transmitter module, and the Arduino will display the data on the OLED display. Now let's talk about interfaces. This E32 LoRa module support UART protocol. It means it uses TX and RS to communicate with the Arduino Nano. In the same protocol, we use HC05 Bluetooth modules. So these modules are very easy to use, just like serial monitor you use. So you just have to give the data which one you want to transmit using the UART protocol. It means serial communication to the E32 module, and this E32 module will transmit the data, and this E32 module will again receive the data and will send the Arduino via again UART protocol TX and RX, and then you can do whatever you want. You turn on or off a LED, or you want to display it on OLED module. And as you know, this kind of OLED works on I2C module. So this was the full hardware interface here. Now let's talk about the antennas which I am using with the E32 LoRa modules. Basically, I am using this kind of rubber ducky antennas for short range communication. I bought them from robo.in. They are very cheap, around 55 rupees or 45 rupees per piece, and they can turn also in 90-degree angle like that. And these antennas are not very bad, although there was mentioned they are 3.5 dBi, but I don't know the reality. And for long range communication, I basically use this monopole antenna. This monopole antenna is tuned for 433 MHz for this kind of applications. And as you can see, this is a magnet, and this monopole antenna is recommended to use over a metal surface like this, or you can mount it over your car, and these magnets attach it with like this. And actually now this metal surface is acting as the ground plane of this monopole antenna. So I had used this antenna before, and it performs pretty well comparing with that. Also, you can attach one of this antenna with your RTL SDR, so that you can monitor the LoRa module signal on your laptop screen using the RTL SDR software, SDR Sharp. All these antennas I am showing you here, these are omnidirectional antennas. It means these antennas can communicate 360-degree angle of this antenna. But if you want to communicate very long distance but a particular side, you can use Yagi antenna or corner folded dipole antennas. Those are heavily directional and high gain antennas. They can communicate on only one direction, but they can communicate up to 2 times or 3 times more comparing with this kind of omnidirectional antennas. I will set this transmitter module on my rooftop, and this is the time of monsoon. That's why I had made this watertight box for the transmitter module. As you can see, the transmitter module with its antenna will go inside the watertight box, and this is the antenna connector for the transmitter module. Here is the SMA female connector of the E32 LoRa module, and this is a SMA male connector. It will go directly here, and opposite side of the cable is connected with the BNC connector, and the opposite side of the BNC connector is coming out of the box. And this is fully water sealed. As you can see, I had applied here silicone glue, and the transmitter module and its antenna will go here like that. And this will be fully weather sealed, and my antenna will be connected here with the BNC connector. I will attach this kind of converter BNC to SMA to the SMA female here. And now here I can connect any kind of antennas SMA connector, as you can see here. So now let me tell you for this experiment which data I will transmit using the transmitter and which data the receiver will receive. So as you can see, our receiver is already powered up, and here is a red LED is glowing, and the display is displaying, but there is no any data, only the interface. And this is our transmitter. Here in the transmitter, here is a voltage divider. As you can see, these two resistors are actually the voltage divider. Using the voltage divider, we can actually read the transmitter module's input battery voltage, which is connected here. So if I power up the transmitter module, as soon as the transmitter will power up, as you can see, the receiver's LED is turned into green from red. And here on the Arduino Nano, TX LED is glowing each and every second. Actually, the transmitter Arduino is sending a counter 1, 2, 3, 4 onward in every 1 second, and the receiver is receiving that counter. Here you can see the counter which is increasing 32, 33, 34, and also with the counter data, this Arduino Nano is reading the input voltage of the transmitter module and sending the input voltage of the battery to the receiver, which is here 7.68 volt in the bottom line voltage. So in this way, from distance I can also know the remaining battery voltage of the transmitter, and I can decide when I have to detach the battery, because this kind of lithium ion batteries, if we discharge the maximum level, the battery already goes down and never recharge again. So that's why I had also sent the battery voltage data with the counter also. So this is our full transmitting and receiving data setup. So that's it for now. In details, I will show you how the counter is counting, how I am sending the counter, how I am reading the input voltage level of the transmitter module in the code. Later in this video, I will explain the code. And here again, if I disconnect the transmitter module from the power, the receiver's LED will automatically turn into red. So these are the basic functionalities of the transmitter and the receiver. Now let's set up our transmitter on the rooftop here. And here I am on my roof. As you can see, this is our transmitter inside the watertight box, and this is the transmitter you can see here. it's running already. The Arduino Nano's red light you can see here, and this is the battery. With the connector here, I had connected the monopole antenna. I had shown you before. This is the metal ground plane, and these are for heavy weight because this is very high. You can see the approximate height here. I am on the second floor. You can see here second floor or 3 tola we specifically says, and this is the height. And this is our receiver. The receiver is turned on already, and you can see the green color light here. Green light means the transmitter is already turned on and the receiver is receiving the data, and the display is glowing here, but you cannot see the display here. I will show you it later. So our transmitter setup is already ready, and I am going to cover the transmitter box with the plastic wrap and the thermocol box due to prevent the overheating and rain issue, because as you can see the weather is not very good. Heavy rain, heavy sunlight, anything can be happen, so we have to prevent our transmitter properly. Actually this box is watertight, but it cannot prevent the heat issue, so I have to use this here. So here my transmitter is under the thermocol box, and you can see here is my transmitter antenna, monopole antenna, and the receiver is receiving data successfully. So let's go outside and check how far we can communicate with these modules. And as you can see, this is a semi-urban area. It means no way to get any line of sight. So this is the proper place to test our LoRa modules transmission range in urban area, I think. So here I had connected my 433 MHz rubber duck antenna with the RTL SDR, and I am running the SDR Surf software of RTL SDR. If I run the software, here you can see a signal here, and I had tuned. It means this signal is directly coming from the LoRa transmitter. You can listen the signal. In each and every second we are getting a new signal here, and you can see the signal strength here. The signal strength is very good, and here is our LoRa receiver. Here indoor condition you can read the display also. In the display we are getting the counter number. This number is updating in each and every second, and the bottom line you can see the transmitter's battery voltage, which is currently 8.14 volt. So this is the total receiver setup, and I had shown you the display properly, and making this display interface takes a very long time. So let me know how this interface is. And here I had also tuned my Baofeng radio, and if I turn the volume up, you can receive the signal here. You can listen it. It is a digital signal, that's why it's that much ugly signal, but this is containing the whole data. This is transmitting by the LoRa module. It's heavily raining, and the transmitter is on the rooftop, and the transmitter is transmitting also. We are receiving successfully the signal, so it's properly waterproof. So here I am after a heavy rain. Let's check our modules, how much watertight they are. So this is the antenna, and it is fully wet, but no issue, it is okay with it. Let's check our main transmitter unit, and I can see inside the box it is fully dry, so no issue, it successfully passed it. Now let's go outside and check the original range of the LoRa modules. So currently I am in my friend's house, and I am around 850 meters away from my transmitter, and here you can see a stable signal. The green LED is constantly lit up here, and it's fully urban area, no direct line of sight here available. So let's go far away from this. Here as you can see, this green LED is glowing here, and currently we are around 3.2 kilometer away of our transmitter, and as you can see this is not any kind of line of sight here. I am around 3.2 kilometer, and where the transmitter is on a urban area. So with this module we can communicate up to 3.2 kilometer. We had tested, but these modules are rated up to 8 to 10 kilometer on direct line of sight according to its datasheet. So I think if we change the antenna with the corner folded antenna or Yagiuda antenna, we can communicate more distance, and this is we are getting with just a simple monopole antenna which is omnidirectional. So we will conduct more experiment with these modules and modifying the antenna in future. So if you are interested on those antennas videos, you can do subscribe our channel and stay tuned with me. And I am again showing you, this is the stable signal as you can see here. Okay, now let's see what is the original distance between our transmitter and receiver. This is my house. Here I had set the transmitter, and this is the exact area where we are right now. And as you can see, this is approximately 3.3 kilometer, and 3.3 kilometer without any line of sight stable connectivity is a very big thing. So this is the proof also. So first of all, let's explain the circuit diagram of the project. So here are our all components from both transmitter and receiver. Let me explain you. This is our E32 LoRa module, and this is our Arduino, and this is the logic level converter. Here you can see these are two LEDs, one is green and one is red. Green one indicating the connection is okay, and red one is for showing that connectivity lost. And these are our voltage divider and display, OLED display, which we had used in the project. So let's start from the main parts. This is our E32 LoRa module. It have total 1 2 3 4 5 6 7 pins: VCC, ground, TX, RX, M0, M1 and auxiliary. And here is our Arduino. You can use any kind of Arduino like Arduino Uno, Nano. I had used Nano here, and you can also use Arduino Pro Mini or Mega also. So pin configuration for all of them will be the same. And E32 LoRa modules signal pins are not 5 volt tolerant. That's why here we had used a logic level converter. Actually Arduino runs on 5 volt. That's why its digital pin signal are also of 5 volt, but E32 module signal pin are only 3.3 volt tolerant. That's why we have to use a logic level converter here, which will convert the 5 volt of the logic level into 3.3 volt without destroying the signal. So let's explain the total connection. If you want to use the E32 LoRa module in its maximum power, you have to provide its VCC and ground to 5 volt. Remember this, to get maximum power you have to give it 5 volt in VCC, but its digital pin are only 3.3 volt tolerance. This is the main thing here. So we are powering up the E32 LoRa module's VCC from directly the Arduino 5 volt, and the ground is connected with the Arduino's ground, and all grounds in this circuit are already sorted. So VCC of the E32 is connected with the Arduino's 5 volt. Arduino's 3.3 volt is connected with the logic level converter's low level voltage, which is 3.3 volt, and logic level converter's high level voltage is connected with the 5 volt of Arduino. Grounds are all sorted as I had told you before, and we are using 4 channels of the logic level converter here, channel 1 2 3 and 4, because here we are using 4 pins of E32 LoRa module. There are also a auxiliary channel, but we are not using the auxiliary channel for particular this project. So here are 4 pins to communicate with the E32 module, which is TX, RX, M0 and M1. TX is the data transmit of the E32, which pin E32 used to transmit any data to Arduino. The RX pin is to receive any data from the Arduino to the E32. M0 and M1 are used to set the configuration or operational mode of E32. So for this project, M0 and M1 are not that much useful, but we had also connected that with the Arduino, so that if in future we want to change the E32 modules any configuration, we can do it from here. Here we are using the software serial function of the Arduino Uno, using which we can convert any digital pin into a UART protocol TX-RX pin basically. So D8 pin of the Arduino is acting as a receiver. That's why it is connected with the transmitter pin of the E32. Remember, in UART protocol, first devices TX will be connect with the second devices RX, and second devices TX will be connect with the first devices RX. So this is a cross connection because one will transmit and other will receive. So this is the basic funda here. And we are using D2 pin to connect with M0, and D4 pin is connected with the M1. So the first channel of the logic level converter, we had connected the RX pin of the Arduino, which is D8, and the channel 1's low voltage side is connected with the TX of the E32 LoRa module. In the similar way, D7, which is the TX of the Arduino, is connected with the channel 2, and low voltage level channel 2 is connected with the RX of the E32 LoRa module, and D2 and D4 are also connected with channel 3 and channel 4 of the E32 LoRa module, which is M0 and M1. Auxiliary is not used here. Now let's come to the LED section. Here are 2 LED I had used. One is green LED and another is red LED. Here we had used a 1 kilo ohm resistance for both LEDs, and The green LED is connected with the D5 and red LED is connected with the D3. You can also configure all these pins if you change it in the Arduino code. I will show you Arduino code after the circuit diagram explanation. So these are the green LED and red LED connection for the Arduino. And now let's come to our OLED display and the voltage divider. The voltage divider is connected with the transmitter module so that we can display the transmitter's battery voltage on the receiver display. So there are two resistors in the voltage divider. One is R1 and the second is R2. The ratio of R1 and R2 basically used to sense the voltage in the Arduino's analog pin. So you have to manually measure the R1 and R2 resistance value using a good quality multimeter. After that you will get a proper voltage reading on your Arduino display. So the transmitter Arduino's analog 0 pin is actually connected with the voltage divider, which will use to sense the input battery voltage. And let's come to the display section. Here we are using a 128x64 OLED display which works on I2C protocol. That's why it has total 4 pins. Actually the VCC pin of the display is flexible. You can connect it with both 5 volt or 3.3 volt, whatever you want. And the ground will be connected with the ground. The HDA pin of the display will connect with the A4 and the SCL pin of the display will connected with the A5. So the display will connect with the receiver section and the voltage divider will connect with the transmitter section. So that is the full explanation of the circuit diagram. I had drawn it by my hand. It is not that much good, but I hope you can understand the circuit diagram properly. If you have any kind of query, you can let me know in the comment section or directly message me on Instagram. I will help you definitely. So this is our total circuit diagram. Now let's explain the transmitter and receiver codes. Now let's explain our Arduino codes. So this is the code for the transmitter section. At first we had included one library which is software serial. Basically using this library we can use Arduino's any digital pin as a TX or RX as like as the TX RX of UART protocol. So at first we had included the library software serial.h. Then we had defined all pins. The N0 pin is connected with the D2 of the Arduino and M1 is connected with the D4 as I had told you before in the circuit diagram. And for TX and RX pin we are using the 8 and 7 of the digital pins which is named as LoRa serial, and here as you can see software serial. Now here this part is to sense the input voltage of the transmitter battery. So at first we had defined the analog pin which is A0. It means we are using A0 pin to sense the battery voltage. And now there are two resistors R1 and R2. We have to manually measure the resistance value using a good quality multimeter, and we have to put the resistance value here. And here I had used two resistors. R1 is around 20 kilo ohm and R2 is 4.5 kilo ohm. So these are the exact values of the resistance, and here is the reference voltage. For better result you have to measure your Arduino's analog reference voltage pins voltage and update here. Otherwise you can keep it 5 volt just, but that may not be that much accurate. So it is better to measure and update here. And this is just to start the counter. So we had started serial.begin 9600. Only this part you have to modify to get a proper voltage level, and this part you have to modify if you want to change any pins of the Arduino's used in the code. And the later part you don't have to do anything. It is automatically calculate the input battery voltage and automatically high or low the M0 and M1 pins. As you can see M0 and M1 two pins are here low, because in normal transmission mode we have to keep these two pins in low. And this section it is actually sending the counter value and the transmitter voltage level with the serial print function, because these modules support UART protocol as I had told you before. So this much is the transmitter Arduino code. All the codes, circuit diagrams and everything I will give you a link of a Google Drive in the description box. You can download them from there. Please check the link on the description box. So this was the transmitter code. Let's explain the receiver code. So this is our receiver code. Here are some other additional libraries, because in the receiver part we had used a display and other things. So at first again we are using software serial.h library to communicate using software serial, and oy.h adafruit underscore gfx adafruit ssd1306. These libraries are for basically the OLED display, and here is the resolution of the screen, which is 128 cross 64. And again we had defined the M0 pin and M1 pin, and again the RX TX pin. These are same in the all code 8 and 7. Here we had defined the LED's pin number. The D5 digital pin is connected with the LED receiver, which is a green LED, and D3 pin is connected with the red LED, which is LED timeout, basically data lost. And here we are taking a 3-second delay. If more than 3 seconds the receiver does not receive any kind of signal, it will turn the red LED on. And in this main code we are just receiving the incoming data from the LoRa module using again UART protocol, and here we are displaying the incoming data on the OLED display. As you can see here, you don't have to change anything here. You just have to properly tune R1 and R2 value in your transmitter section to get the proper voltage, and the receiver will show your transmitter battery voltage. So these are the two codes, not very long code, and I will also upload this code on a Google Drive link, as I had said you before. So to download them, check the description box. So this was the full range test video of eByte E32 LoRa modules. Hope you like it. And shooting this video was very hard because, as you can see in the video, heavy rain, 48 degrees centigrade temperature of Bakura in this summer. So I think this video deserves a like, and let me know in the comment section please. And I will also upload more videos on this E32 LoRa modules by modifying its antenna with DIY antennas like handmade dipole, 7-element Yagi antenna, reflective antenna, or GP antennas. The transmission quality and range fully depends on the antenna. So as a ham radio operator, I can make various kinds of antennas, and I will make videos on that also. If you have any question, queries or suggestions regarding this video, please let me know in the comment section, or you can directly message me on Instagram. My Instagram ID is on the description box. And also, if you want to have the circuit diagram and transmitter and receiver both codes of this project, you can check the description box. You can download it from there easily. Hi, I am AkashWave, call sign Victory Uniform number 3 Hotel Alpha X-ray. I am an electronics and communication engineering student and a licensed ham radio operator also. I used to make videos on microcontrollers, microprocessor, RF module, ham radio, RTL, HDR, various kinds of antennas, and this kind of projects. So if you are interested in these things, please consider to subscribe my channel. And as you can see, my English is not that good. Please consider it. But I think what I am trying to say through this video, you can understand it properly. And I think that's more than enough. So that's it for today. See you on another video. Bye.